So last we had seen about exception, and we had begun with the exceptions. Yeah, what we have seen in exception so far? How to throw. And what can be thrown? Throwable. Whatever is throwable, that can be thrown. And so Java is simple. Okay, fine. We also saw about the runtime stack, how execution happens in the runtime stack. And let's have a look at that also. Okay. Fine. The main thing what we want to look at today is we would like to look at this class called throwable. That's one thing. What is this throwable class? What are the methods here? What constructors are available? Fine. Okay. Fine. So for that, before we go into this, let's look at. Fine. Let's again review how execution happens in the runtime stack. Okay. Fine. So what exactly happens in the runtime stack? If you have to execute a method, right? The method main has to be executed. Fine. On the runtime stack, a frame is created for main. If main invokes a method, let's say m1, we'll have m1 here. Okay. Fine. Method main at this point, yes, it's calling method m1. Fine. A frame for m1 would be there. If m1 is invoking another method m2, yes, we have a frame for m2 on top of it. Fine. Okay, these two are frozen, right? They are not working. If m2 is calling m3, yes, we have the frame for m3. The topmost one is the one where the execution is currently on. Fine. If the frame which is above, if that finishes, then the next one, there's nothing on top of it, it can now proceed to the next step. Fine. Okay, whether to proceed with the next step or what's the other option? It depends. When this is finishing, how is it finishing? If it's coming out properly, I will proceed. If it is throwing, throw. Then everything falls. Fine, that's what we have seen. Clear? Exception, oh, then it is exception for all, one by one. Okay, so keep this picture in mind. Fine. And now let's start looking at this class called throwable. An object of throwable represents a error condition. If there is an error condition, that's where we will create an object of some subclass of throwable. Fine. So when you create a throwable object, the constructor for throwable, what does it require? Fine, let's see this. So the various constructors for throwable are like this. You can create a throwable by specifying a string for the message. Fine. Yeah, it's an error condition. So put an error message in an object of throwable. That's one thing which you can have. Okay. Fine. Other constructor, of course, is there where you might not specify anything. It's just a simple throwable constructor. Fine, when nothing is specified, no message is being stored. Okay, fine. Another constructor for throwable. A throwable can be created by specifying another throwable. This is nothing but, we call it as cause. What is the cause of the throwable? A throwable can use another throwable as a cause. We say this is nothing but chaining of exceptions. This is allowing chaining of exceptions. Fine, we'll understand this one. Fine, what is this chaining of exception? And of course, what we also have is another constructor where we'll have two parameters. You can have a message as well as a throwable object, cause. Message and cause, both things are available. Fine, in the constructor you may specify. Fine, so this shows that yes, internally a throwable object would be managing at least two things, a message and cause. Cause is just another throwable object. Oh, what is this cause for? Why do we have something called cause? Okay, fine, let's understand this. What is this cause? Okay, To understand this, yes, we can take that same example, that real world example, florist example. Okay, if we take that florist example, uh, fine, what was that florist example saying? Yes, we interact with JK florist. We are saying send flowers, invoking a method like send flowers. Okay, send flowers on JK florist in turn invokes a method called send flowers on KK florist. And there's some object KK florist. And this in turn he is invoking the method on a flower producer, that's get flowers. Fine, specifies two things. And then he interacts with the delivery boy. And when he interacts, he says deliver. Fine. In the execution of the deliver method, fine, what's happening? Yeah, what was happening here? What does the delivery boy do? He wants to deliver, but then what can happen? When there can be an error there. So when the error occurs, what does he do in the real world? What will he do? Prepares a memo. Fine. This is where is KK Florist? He's in Kolkata. Okay. Now, if this memo, which is prepared by him, what do we understand? What will okay? He throws a memo to KK Florist. What will KK Florist do? That same memo goes to JK Florist. Fine. And JK Florist puts the same memo to you. Okay. Now, look at this problem. The delivery boy is in Calcutta. The memo he has prepared is in Bengali. Okay, is it useful? Bengali. Who can understand? Yes, KK Florist does understand this. He can understand being in the same town. But then, is it useful to others? So, what do you think KK Florist should do now? Huh? He should prepare his own memo. See whether he understands or not. There is basically some understanding between these two, that how I'll give a memo. Fine. That's a memo from the delivery boy. Okay. A delivery boy gives a memo to a KK florist. Fine. The KK florist, yes, what will he do? If I got a memo, oh, I don't pass on the same memo. Let me prepare my own memo. He has his own format. Fine, he'll have his own format. And what will he do? He can just throw that memo, but then this guy will say, give me some proof. So as a proof, I'll have to put an attachment. To my memo, I'll put a copy attachment. Oh, this memo I have prepared based on this. This is the proof. That's the report. Clear? What is that other thing? That was a memo. In a memo, you are attaching another memo. In a throwable, you have a cause. This throwable is created because of this.
Mentioning the problem.
That is another fine. I got a memo. But I'm not going to just throw that same memo. I have my own memo. I'll create my memo, but then I'll put that memo along with this. Make both that memo also available. That's our constructor. If you create a throwable, you can put cause, which is another throwable. Clear? Fine. Why we have this? Okay. Fine. I'll give another example. Okay. Fine. So this was from real world, right? Now this also is an example, fine, which is just to understand why such things are there, right? Why we might have such cause. Why do we need a cause? Why need to create a new throwable object? And from real world, it's very visible, right? This is what is going to happen, right? See the understanding. These are at different layers. Now, just understanding a few things. Let's take a very simple kind of an example. Okay, uh, many times or most of the time, a good development would be such, a good architecture would be such where you basically have layers. Fine. See, in your machine, there are basically layers which are working. You have a hardware layer. On top of the hardware layer, there is the system layer. On top of system layer is your software. Then we have your applications. Fine. Okay. So you have your layers, right? One layer talks to the next layer, right? So there is an understanding between the two layers, right? Fine. Now just think an error occurring at a very low layer. Fine. Whatever is occurring, error occurring at that low layer, is it the same thing that should be reported right at the top? No. Fine. Fine, we understand this. So from that point of view again, so considering this layer, this basically why we should have this throwable being created and used as an attachment, right? Right, it's just we call it here. It is known as chaining of exceptions. There is nothing but we are creating a chain of exception. An exception. Oh, I have a cause, but then oh, someone creates another exception. For example, here also when he throws this, the exception, the memo which is there is having it's two memos basically which he has received. One memo with an attachment, which is other memo. He creates his own memo further. Fine, to put his name there. Okay, this is from JK Florist, but that has an attachment which is nothing but the memo from KK Florist having the attachment which is the memo from delivery boy. Fine, and that's what is being thrown, right? So it's a chain. Fine, it allows for. So this is nothing but making a provision for chaining of exceptions. That constructor is there to allow chaining of exception. So throwable being created with the help of a throwable, which is the cause. So whenever you get a throwable, you can look at the cause. Fine. If that is null, that means that is the root cause. Fine. There's no other cause. It's a root cause. Okay. Fine. If there is a further cause, yes, you go further and further till you get a this cause. This throwable doesn't have a further cause. That means it is the root cause. And that's where the original thing generated. Okay, so another example, and on these lines where we'll see the layers thing. Okay, API layer. So to understand the API layering, uh, consider that you are having an object. Fine, we'll talk in terms of objects and methods. Okay, so you might have an object called RDBMS. Okay, what operation do we do on an RDBMS? Maybe we are doing a select operation. Fine, fine. Let's understand. Oh, there's an operation of select. So you might have a method called select. Fine, and it would give us some rows and columns results. It gives us results. Okay. When you call select on an RDBMS object, what will it do? What is the RDBMS having?
Database.
Yes. What does it manage? It would have to manage its data on files. What it will manage is, okay, this table is the data for this table is so and so files. Maybe there are multiple files or whatever way. Fine, it has to have all that information. Fine. So when you say I want to select from so and so table, what will it do? It will have to read from the files. For reading from the files, when it finds out which file it is, and then for reading from the file, it has to interact with the OS. Fine. So we have an interaction. This is select is the interaction with the RDBMS which the user has, and the RDBMS in turn uses an operation called read file. It will say I want to read from so and so file, and it goes to the I want to read this file. Read operation would be done, right? Okay. So when it goes to the and says read file, yeah, what does OS do? OS is managing files where? On the hard disk? Okay. hard disk, it is managed sector wise. Fine, it is managing things in sector wise. Therefore, when you say I want to read this file, it will say, oh, this file, which are the sectors it is occupying on the disk. Fine, it would have its own mechanism according to the whatever file system it is using, and then it has to interact with the BIOS. Fine, and it will say to the BIOS, it will say, read so and so sector for me. Fine, see, we can see the layers here. Fine, think of these as methods. How you call a method select. Select has to in turn call a method called read file. Read file in turn has to call a method called read sector. Now what happens? When read sector is called on the BIOS, BIOS will try to read from the hard disk, give the result, right? When it goes to read the hard disk and tries to read, it says there is a CRC error. Yeah, what is CRC error? What is CRC error? Yeah, it can't be understood by the one who uses the RDBMS. See, it's not something, it's too technical for someone who is at this stage calling select. If he gets CRC error, he doesn't make out anything. And he's not interested. And trying to understand what is this CRC, leave it. Fine. What is CRC? What? Cyclic redundancy check. So there is a CRC error, which was the error. So it's throwing an exception. What is throwing exception? Read sector. See, read sector, who will call read sector? Obviously, not the one at the layer of RDBMS, not at the layer of, but the one who uses OS. Oh, he is very familiar. He understands what is meant by CRC. We are not the ones who are writing OS. And therefore, it's fine. We don't understand what is CRC. Clear? So, see, there's layers. Each method, now understand this. Look at a method. What is a method? Some operation. It has inputs and it produces. If successful, it will give a output or it can have errors. Entire thing is a method signature. Return type, method name, parameter list, that's the input, and throws. Clear? Even throws is important. It's part of the method. When you talk of a method, you should always talk of, fine, you can't write a method without saying, oh, what's the return type? What will I get from this? You must mention the return type. Same way, return type is showing us success scenario. Throws is also giving us failures. What failures can be there must always be mentioned when you write a method. Think of method, always decide, this is the kind of object I am creating, right? In this object, I will have so and so operation. Fine. If I have an object of this class, it will allow so and so operations. Fine. For this operation, these are the inputs I need. This is what I should return, and it can have so and so failures. And that's how your thinking should be, without even writing the method implementation. Whether you write the method implementation or not, it might be abstract method. Fine. Just like we saw last time, the example of vehicle class, you have a method called run. We don't write the code, it's an abstract method. Run is abstract method, but you would put the throws there. Fine. Think about throws. Okay, always. Whenever you design your methods, always think about failures and put the appropriate throws. They are important part of a method. Fine. So see this method, what are the methods in BIOS? Like read sector, they would be designed for the one who understand the BIOS. And therefore the throws there is accordingly there. Fine, the exception like CRC error is in read sector because that's appropriate for the users of BIOS. Yeah, it's appropriate for the users of BIOS. Okay, and accordingly the methods, the throws is decided, right? So now when he throws an exception, what will the OS do? Fine. OS should not let the CRC error be thrown. OS will say, oh, there is a file read error. It might say, oh, there is a file read error, but what's the reason for file read error? It will say, oh, I have a cause. So it will create object of file read error. Fine, it will throw file read error, but before throwing in the file read error, while creating it, it will say, okay, the reason is CRC error. So if someone wants, even at a higher level, someone, if he understands them, fine. If he wants to explore that, he can explore. Fine. So we are keeping the chain. Fine, chain. It's like the attachment, right? Okay. Clear? So this read file, when someone designed read file, he'll say, oh, read file, what error it should have? It should say file read error. Fine, that's the exception. It shouldn't be saying CRC exception, because who's the one who is going to use the read file? The one who is writing the RDBMS. Fine. And when someone says select will say, oh, what is this? Why should I let him know that there is a file operation or where am I storing it? Fine. Let the user not be interested. He may not be interested. So he'll say, oh, there is some IO operation which has failed. So there is an IO error. Fine. It might be select might be saying, oh, there is an IO error. Read file will say, oh, there is a file read error. And read sector will say there is a CRC error. Clear? The root cause is the CRC error. Clear? Root cause is the CRC error. Fine. So clear about that. What is this cause? Fine. The constructor with cause also. Okay. Fine. Now continuing with the methods of throwable. Fine. Throwable constructors we have seen. Okay. 4 constructors are, yeah, we have 4 constructors, right? Just the message without anything at all, or you might have a cause, or you might have cause as well as the throwable. Fine. Cause as well as a message. Sorry. Yeah. Fine. 4 constructors. Okay. Looking at the methods of throwable. Nothing. There's nothing. There's only the name of the class which you'll know. And you'll only know the name of the class. Fine. Okay. Fine. Methods of throwable. Okay. So now I'm looking at methods of throwable. Yeah. Get methods. So we have method called public methods here. Okay. To return a string, get message. Right? There's a get message. There's another public method, returns throwable. This can be null also fine. So we have the method called get cause. Okay. We don't have a method to set the message. When you create the object, that time you should have specified. See, the concept of chaining of exceptions came at a later stage. It didn't come with Java 1.0. Fine, message was there in throwable class right from the beginning, whereas cause has been introduced from Java 1.4. Okay, fine, that's from Java 1.4 onwards. Okay. Fine, so we have now it's like we have the get cause method to get what is the cause object, but it's also there because there is some old API, fine, which may have to be updated. So for that reason, fine, what was also made, the provision was done where we would have a method which returns void. The method is init cause. It's not called the set cause. Init cause, initialize. Fine. And you can specify the cause. Fine, you didn't give in the constructor. You might have created without the cause, and then you might say init cause. That is the idea here. Now, when you say init cause, if it was created with some cause already, if the cause is already set on this and you're saying, oh, let me put another cause, then this will fail. It will not change. Okay, init cause is not, it's not saying set cause. Fine, it's not for changing. If it is null, okay, I can set it only that way. Init cause only works if it is already null. The return type, method's return type is void. You're setting it on the object. Okay, init cause. Now, fine. So this gives an impression there are only two items in our throwable object. Actually, when a throwable is created, there are three things in a throwable. There is one more method. Fine. This method's return type. It's a public method. Return type is an array of a class called stack trace element. We have a class called stack trace element. And this is a method called get stack trace. Okay, we have the method called get stack trace. Fine. Let me put a few other methods and then we'll come back and try to understand. Stack trace related methods. Fine, we are looking at this stack trace thing. The stack trace related methods, we have a method whose return type would be void. There's a method called print stack trace. Okay. And this one called method returns void. Name of the method is fill in stack trace. Fill in stack trace. Fill in stack trace. Fill, F-I-double-L, fill in stack trace. Fine. Let's understand this method. Okay. When a throwable object is created, fine, you might be giving two parameters or maybe one parameter, no parameter, whatever you may do. The constructor of throwable, fine, inside the constructor of throwable, it is calling the method called fill in stack trace. Okay. What is being done? It is invoking the method called fill in stack trace. Fine. What is the effect of fill in stack trace? Let's see that. For that, let's go back to that picture of the stack trace. How execution is happening, right? The execution is happening in a stack trace. Okay. So let's say at this point in method M3, fine, you are calling the constructor of throwable. When you call the constructor of throwable, it would in turn be using the method called fill in stack trace. What fill in stack trace is supposed to do? Yes, when we say create an object of throwable, there is some object of throwable being allocated. So let's say there is this object of throwable which is allocated. Fine. In this throwable object, provision of two items we have already seen. There might be a reference to a message, or this is your message. There might be a reference to another throwable object. This is your cause and other thing. Fine. For chaining purpose, we understand there is a message and cause. There's a third item which now is filled with the help of fill in stack trace. Fine. What fill in stack trace is doing is, it's saying at this point, whenever we call fill in stack trace on a throwable object, we call it on a throwable object. On this object, the one which is being created, on this it has been called. Whenever it is called, what it does is, it looks at the runtime stack. It is like, take the picture of the runtime stack and keep it in this. Take a snapshot. Currently, what's the picture here? And put it inside your throwable object. Find picture of this. So what's the picture here? Oh, how many frames? 1, 2, 3, 4. Oh, there are 4 frames. Fine. Because there are 4 frames, what it is doing is, it is allocating an array with 4 elements. Okay, fine. This is my array with 4 elements. Each one has an object of what type? Stack trace element. There is a class called stack trace element. One object of stack trace element per frame. The object of stack trace element has information about a frame. It's nothing but information about a single frame. The array size is how many stack traces, how many frames were there in my runtime stack when this object was created. Fine. When this fill-in stack trace was called. Fine. Calling fill-in stack trace on a throwable is take the picture of the runtime stack and keep it. Keep it in the throwable object. Clear? So at this moment, what's the picture? 4 items, 4 frames. So 4 items. For each item, information. Let's see what information goes in one object of stack trace element. Fine. One item, one object for one frame. Clear? There is one object of stack trace element for this frame, another for this frame, another for this frame, another for this frame. Clear? The array size would be 4. So you get 4 objects in the array. 1 per frame. Fine. Let's see. What is the information you might be interested in? 1 frame. So what's the information available from stack trace element? Now we look at methods of stack trace element, not the methods of throwable, okay? Fine. Temporarily, let's shift to methods of stack trace element. Okay, so methods in stack trace element. Once, okay, let's just look at it here itself. What do we have? What is this frame? What is this frame corresponding to? It corresponds to some method. Fine. So we have a method called get method name returns a string. Stack trace element is saying this frame, on this frame we have so and so method. So get method name. Method belongs to class. Objects are of a class. Fine, objects are of a class. Right? So fine, this method is from so and so class. So we have a method called get class name, get method name, get class name. Fine, one frame only, right? We have so and so method. This method is from so and so class. Where is the class defined? Where do we define a class? In a, put it in a, where is our class definition? In a file, in a Java file. So we have a method called get file name. It will say so and so dot Java file. Getting the file name. And not only getting the file name, currently see each one is currently stuck. It has a program counter where it is, what it is currently executing. Each one has that, right? Fine. Even M3, I'm currently executing so and so. So this statement, whatever is the current statement for that frame, is a line number in my Java file. You have a method called get line number returning an integer value. So 4 pieces of information per frame. Fine. It's a method. Fine. Which belongs to a class which has been defined in a file and currently executing line number so and so. Fine. See, whatever line number it may be specifying, on that line, if you look, it would be nothing but a call to method M1. The line on which it has called the method M1. In same way, this method, it's a method called M1. It's part of so and so class definition. That class was defined in some Java file, and currently the place where it invoked M2, that's a line number. Fine. And that's a line number. Fine, you can make out, right? So same way here. So each of those frame, fine, you can make out now. Okay. So what is happening when a throwable object is created? Whenever any, see, it's not occurrence of an error. One thing, it is nothing but someone creating an object of throwable. Anytime you create a throwable object, whichever constructor you may use, fill in stack trace is called on that object. It is taking a snapshot. Fine. So the time when you have created the object, that time. Fine. It's not the time of throw. Throw is you fine. So if I create the object at this place, but my throw is executed at a later stage. I've created an object, I kept the object, and then I executed a few more statements, and then my throw is occurring at a later stage. The picture is of the time when you created the object. Fine. If you want to throw later, what you can do, the line on which you are calling throw, maybe you can put before that and put a semicolon, then say throw. What you can do is put the fill in stack trace. Call fill in stack trace explicitly. Just ask it to take the picture again. Take picture and then throw. And you can just anytime you can call fill in stack trace to take the picture at that time. What's the picture at this time? Picture of the runtime stack. When execution happens on the runtime stack, picture can be taken by a throwable object. It's fine. It can be stored in a throwable object with the help of fill in stack trace. Clear the method called fill in stack trace. Fine. And then we have the method called get stack trace to return an array of stack trace element. That picture, whatever was taken, you can take it out. Fine. Okay. Let's go back here. Yeah. So fine. I'll put the methods of stack trace element. Fine. Let me. So we have the class called stack trace element. Okay. And in this class, stack trace element, the methods which we have, right? What are the methods? 4. Method to return string. Yes. A frame. Find information about a frame. First thing. Method. So get method name. Method belongs to class. Get the class name. Class defined in a file. Get file name. And currently executing statement on a line. Line inside the file. So in that file, get line number. Returns int value. Line number as an integer. And 4 get methods of the stack trace element class. This is from stack trace element. Fine. Stack trace element is here. Get method name string. Get method name. Return type is string. As a string. Method name, class name, file name. They are strings. These are the. This is for one frame. What does that method return? Get stack trace return? It returns an array containing such objects. Fine, it returns an array containing all such objects. Fine. And we have the option of just saying print stack trace. You may not say get stack trace. If you say print stack trace, fine, it will use the method of fine. Fine. So these are methods of stack trace element. Okay, we continue with the methods of throwable. Okay, Throwable has overridden the toString method. It overrides toString method. In the toString method, it's returning the class name, the name of the exception class, fine, and then colon followed by message. That's a toString. Fine, toString is class name colon message. If there is no message, then only the class name. Fine, class name colon and message. That's what the toString is. Whichever is the object. The object is of a class. The throwable object is of some actual class, right? You have a negative mount exception class, let's say. Fine. So when it is for that, yes, it would give the negative mount exception. That's a class name. Fine. It's an arithmetic exception object. The toString method there would say arithmetic exception colon whatever is the message. Fine. So the class name. Fine. That's what the default toString is. Okay. Fine. So what print stack trace does? It uses a toString. It will show this. It's printing on the standard error. Fine, toString, and then followed by from that array. All the elements from the array are shown one by one. What it will it show? All the 4 information. Fine. The exact formatting for that, you should try out and see the things. How the stack trace is printed. Fine. Another thing about stack trace, right? The stack trace would automatically happen when, suppose the exception which is thrown from here, it's not handled, it's not handled, it's not handled. What happens? It is thrown out from the main and this stack trace is going off. Fine, the stack trace is finished. When the stack trace finishes with an error, this stack trace finished with an error. Okay, if the stack trace finishes with an error, then the default behavior is to call the print stack trace. Oh, this is, I failed because that's an error which occurred. So that it is calling the print stack trace whenever a stack trace finishes, not normally, but by an error. And this stack trace is finishing because main is finishing. Okay, it's finishing because of an error, because a throwable was thrown. Fine. If it is finishing, whatever is the throwable which is getting thrown, a print stack trace is done on it by the system. JVM will do that. Okay. So that way you should be able to see the output of print stack trace. Fine. Yes. Print stack trace is a method which is there in the throwable class. Fine. Yesterday we saw the class hierarchy. Throwable subclasses were error and exception, and then the runtime exception. They all inherit all these methods. All of them have the 4 constructors. All these classes have the 4 constructors. Fine, the 4 constructor we saw. So 4, fine, without parameter, with only message, message and cause, or simply cause. Fine, such things are available for throwable, error, exception, runtime exception. Fine. And clear about the throwable class now. Fine, what's there in throwable? Okay. Now what we should do? We should have our own exception class being created. Okay, so let's create our own exception class. Yeah. Fine. Okay, so let's try creating our own exception class here. Fine. Okay, so maybe let's do it for our class called. Fine, we already developed the few classes in the package bank. Fine. Whenever someone gives a negative value for amount to be deposited, to be withdrawn, or even if someone gives a negative value for the constructor opening balance. In the constructor we have opening balance. If someone gives a negative value, we will not accept it. We'll give a error, and let's call that error as negative amount exception. Okay. Fine. So possible code there can be something like this. We can say, okay, we got package bank, and we can keep our class to be a public class. And public class negative amount exception. But okay, what kind of exception? Want to keep it checked or want to keep it as unchecked? Fine, we normally keep it as checked. Okay, so if you want to keep it checked, we'll say extends from exception. Want to make it unchecked, we'll say it extends from runtime exception. Fine, clear? You want it as checked or unchecked. So accordingly, you have your superclass. Okay, unchecked errors and anything under the runtime exception, that's unchecked. But errors are not the things that a developer should be creating. It's from the library. Fine, the JVM, it's related to the JVM. Okay, fine. So what do we have here? We'll keep one private variable or already messages being managed by the superclass. Fine, we can keep. Okay, so if someone gives a negative value, what was that negative value, right? What is the negative amount value? Fine, that we can keep. Okay, fine, so that can be one additional information, so we'll store that. Fine, everything else anyway message, so we are only interested in message and the negative amount value, two things. So we have private variable, type is long, let's call it as a amount, and we have the constructor. We don't want this object to be created from outside the package. Fine. Others will be using this. They can use the methods, but they can't create this exception and throw it. This exception is meant for bank package only to be created by. It's created and generated here. Others can be using it. Okay, so we'll keep default constructor, we'll not give public access. Fine. So just create amount exception. Constructor requires parameters as a string, a message, and long for the amount. Yeah. So what do we do in this constructor? What does it do? First thing in the constructor, super. Super class constructor has message, and then next step, right? And then provide a getter method. Public method returns long get. You might override the toString method. Yeah. What do we return? Plus, let's add a colon plus amount. And super.toString that will take care of giving class name colon message, and then we have colon and the amount being added further. Fine. So that's a simple way of writing a exception class. You can have your own custom exception classes being written. Fine. Writing exception class is very simple. Just extend from exception. Fine. Here we have added an attribute. Normally people may not even be adding attributes. And you may not be even adding attribute. That's it. Fine. Have the same message. Just pass on the message. Just do super. Fine. Creating the exception class. Fine. Custom exception class. How to create. And how do we use this then? Fine. Where are the changes? What are the changes now? Just think of the changes. And I'll put the code here in this itself for the changes. What kind of change will be necessary? It's part of the bank package anyway. Who is the user of this class? Account class? Current account? Savings account? It's a checked exception. We'll have to have throws clause where? See, now just think independent of whether this exception was there or not. Just independently. You are writing the class called account. You have to write a method called deposit. What do we do? It takes a parameter. Parameter is amount, the type is long. What I should do? I should put a throws. If you give me negative, it's not allowed. And therefore, I'll say it throws a negative amount exception. Fine, withdraw method throws negative amount exception. Constructor, you are taking opening balance, throws negative amount exception. All the constructors. You don't look at the implementation whether I have written a throw or not. This method can fail because you are taking some parameter which we know is allowed to give. The parameter is allowed to give legally, right? According to the Java syntax, it is allowed to be invoked with any long value. Parameter type is long. We don't have a type called, okay, only unsigned long will be there. Fine. Only positive values. We don't have a type which just says only positive value. Fine. Otherwise, I could have said, okay, this method requires only positive value with the help of signature itself. Fine. But that provision is not there, and therefore I'll have to have my failure condition. This can fail because someone might give with a negative value. Fine. The changes. Yeah. Fine. Just we can just put at some parts of the other class called account. Yeah, what's the change? Method signature. I'll give only one example now here. Fine. So the place, for example, fine. Okay. So we have, let's say we have this method public void deposit, which takes long amount as a parameter, and here we put a throws. Let's check if this can be changed. Yeah. Fine. Yeah, within deposit, first thing, if amount is less than 0, then that's a place where we should be using it. Throw new parameters. What's the message? Comma. What's the second parameter? The amount. And then you have rest of the code. Fine, I'm not mentioning. And the rest of the code as it is goes here for the method. Fine, on similar lines, you just have to update the withdraw method and the constructors. And they'll need throws. Yeah, they'll need the throws. And of course, with the if statement, the throw. Fine. See, this will come in the constructor of account with 3 parameters. Fine. In the constructor of account with 2 parameters, you have used this. Fine. What you are using is a statement which has a throws, and therefore you need a throws. Fine. Constructor 1, 3 parameters. You have got, you will be putting throws. Constructor 2, there is no throw statement, but you are using a statement which has a throws. You will need a throws for that constructor. Right? You will be writing a main method. Fine. Test account, class test account. We have a main method. In the main method, when you try compiling, it says there is an error. You have done deposit, you have done withdraw. It doesn't see, it's not executing the code to see whether it's positive or negative. It's not executing it, right? And so you have done withdraw, you have done deposit, but these have a throws. They can fail. And therefore main is also likely to fail because of negative amount exception. You need to mention that in the throws of main method. Main, which is going to call the deposit, the withdraw method, or even the constructor, anything, that would need a throws. Clear? Fine. So this kind of change is needed in the account class. Fine. That's a class you'll have to write first. A class called negative amount exception, and then we have these things. Fine. Clear on this? Okay. Yeah. Practical can be done. इतनी देर में नहीं होगा इसका आउटपुट क्यों Why should it change any output? What we have done is we have only added our own exception class to make a provision that if someone tries with a negative value, that is the only thing which is affected. Earlier, without this, what was happening? If someone tries a negative value, there was no error. Someone says deposit and he says, oh, my amount has reduced. You can take negative values for deposit. It's a good bank. And that's the only thing. Otherwise, the output is same. We have only, what we have done is we are trying to make our class more robust. Find a better one. Just improving our class called account and adding the class called negative mode exception. Fine? Because this is representing a error condition. So we are adding errors. Our class, if you don't give proper values, will be giving errors. That's what we are trying to do. Earlier, garbage in, garbage out. No garbage in. Fine. You want to stop garbage. Fine, that's the difference. Negative value here, that was a garbage. Garbage in, right? Garbage out, you've got your balance going negative. हाँ, निकल है
not that one, like I was